In this video, I will show you how to calculate the magnitude of the electric field from a dipole on a location perpendicular to the dipole axis. In this case, I have the positive charge with a charge of 1.6 10 to minus 19 coulombs and the negative charge with a charge of minus 1.6 times 10 to minus 19 coulombs. The distance between the two, this distance is s, and this is equal to 10 to minus 10 meters in this case. Now I want to find the electric field at location A. The axis of the dipole is the line that goes through the two charges. This is the dipole axis. What I want to find is the magnitude of the electric field at A, and the location A is at the point that is on the line perpendicular to the dipole axis. This line over here is perpendicular to the dipole axis. Since A is perpendicular to the dipole axis, I can use this approximation to find the magnitude of the electric field from the dipole. Now, this approximation is valid only if the distance from the center of the dipole to A is greater, significantly greater than the separation between the two charges. And this is true in this case if you compare the 10 to minus 10 meters and the distance from the center of the dipole to A. And we can go ahead and use this expression. Let's say this is expression 1. This is expression 2 that gives us the dipole moment of the electric dipole. So from 1 and 2, I get the magnitude of the electric field from the dipole at A is equal to the constant 1 over 4 pi epsilon naught times the dipole moment, and the dipole moment is equal to the charge times the separation, and the charge is in this case 1.6 times 10 to minus 19. The separation between the two charges is s, and that is 10 to minus 10. And we need to divide this with the distance cubed, and in this case the distance from the center of the dipole to A is equal to 4 times 10 to minus 8 meters, and this should be cubed. Now if we go ahead and do these calculations, we will find that the magnitude of the electric field from the dipole at location A is equal to 2250 newtons per coulomb. Now note that by using this expression we only found the magnitude of the electric field at location A due to the dipole. We have not found the direction of the electric field.